Today we're going to learn our last type of transformation. What does it mean to transform? To change. Today we're going to dilate shapes. Remember we talked about a dilation when we went to the eye doctor. What are they doing to your pupil? Making it bigger. Dilations, write this down. Make a shape bigger. And then in parentheses put enlargement or smaller. And in parentheses write reduction, because that's the vocabulary that will be used today. Dilations make a shape bigger, enlargement, or reduction, smaller. Now, let's talk about when we make a shape bigger or smaller. So I want you to take your pencil and draw a little square at the top of your paper. Let's talk about a square. All sides are the same. What about their angles? What kind of angles are these? They are all right angles. Does everybody agree? If I take this and I make it 2 times bigger, so let's draw it 2 times bigger. Is it still going to be a square? Yes. Yes. Is it congruent? Yes. What does congruent mean? The exact same. No. Why is it not congruent? Because it's not the same size. It got bigger. Is it the same shape though? Yes. So this is going to be different from our other transformations. This one does not preserve congruence. Now, I'm about to write some answers down to your assignment. I will not go over it again, so if you choose to not write it down, you're on your own. Are y'all ready? The sides, are the sides exactly the same? Look at them. Are the sides?
No.
So this is exactly the same as this? No. The sides are not congruent. The sides are proportional. Meaning, if I make it 2 times bigger, then every side is 2 times bigger. They are not congruent. Did y'all hear me? The sides are not congruent. They are what? They're proportional. Now let's talk about the angles. Write this down. Don't say it. I want you to think about it. Look at this angle. How many degrees is it? 90. Look at this angle. How many degrees is it? Okay. So what would the angles be? Congruent. The angles are exactly the same. The angles are congruent. Why? Because, guys, if a square stays a square, the angles have to be 90 degrees or it's no longer a square. So, yes, the angles are congruent, but the sides are not. The sides are what? Okay, those are the answers to questions 1, 2, and 3 on your assignment. If you can't read it and answer it, I can't help you. Do y'all understand why? Everybody good with why? The angles are the same, but the sides are proportional. Okay, let's move on. Have y'all ever heard of a person who draws pictures of buildings before they make them? What are they called? Architects, and they're making blueprints. Yes? Now, what are they doing to make it look, it's exactly the same besides the size. Say that word again. A smaller scale. So they're taking, pay attention, they're taking like blueprint paper or scaled paper and they're drawing it on what's called to scale. So they might say, hey, 10 feet is going to be 1 inch on a piece of paper. Or 10 feet might be half an inch on a piece of paper. And they're using that scale so that it is exactly the same except the size. Does that make sense? Okay, so they are using what is called a scale factor. A scale factor tells you, write this down. A scale factor tells you how much bigger or smaller the shape will be. The scale factor tells you how much bigger or smaller the shape will be. Now this is important. A scale factor is always a multiplier. Okay, we don't use division for scale factors. We use division to find the scale factor, but once we know the scale factor, for example, how much bigger did I say we were going to make this? 2 times bigger. So you would take the 2 and multiply to get the new side links. Make sense? Yes, everybody good? Now the question is, if scale factors are always multipliers, how would you make a shape smaller by multiplying? Oh, it has to be a multiplier. How would you do it? With smaller numbers. What kind of numbers? Big number. Give me more. Let me say the question again. Are y'all ready? How can I make a number smaller by multiplying? Okay, negatives, you're getting close, but negatives would make it non-existent. Like, I can't measure my desk and say it has a negative value. Say it again. Fractions. Did everybody hear that? Have y'all ever multiplied something by like a half? What happens? What's half of 100? Okay, we good? We good? Half of 100 is 50. 100 got smaller. Guys, refocus. 100 got smaller, but we multiplied, didn't we? So everybody look. Everybody look at my screen. If I take 100 and I multiply it by 1/2, it got smaller. So you can multiply and make a number smaller by multiplying. Are y'all listening? Not just fractions, but fractions that are between 0 and 1. So it has to be like the change in your pocket. 50 cents, 60 cents, 70 cents. Once you get over $1, it's going to make it bigger. So everybody look, 100 times 3/2. Y'all think it's going to get bigger or smaller? It's going to get bigger. Why? 3/2 is $1.50. Watch. Did 100 get bigger or smaller? So, are y'all listening? If you multiply by a number greater than 1, it's going to get bigger. If you multiply by a number that's between 0 and 1, like the change in your pocket, it's going to get smaller. Did everybody understand that? All right, let's look at the rule. You remember we've been learning rules for transformations, right? This rule is super easy. You take the x and y and multiply it by the scale factor. So your job today is going to be to find the scale factor, that number. Now, what would my rule be for this one? How much bigger did we make it? So my rule would be 2x, 2y. Did everybody hear me? I'm going to say it again. My rule would be 2x, 2y. Easy? If I want it 5 times bigger, what would my rule be? 5x, 5y. What if I want it 1/5 of the size? 1/5 x, 1/5 y. Make sense? Now, how do you find the scale factor if they don't give it to you? I just told you it was 5 times bigger or 1/5 of the size. How do you find it? You divide. Okay, now did I say to take the scale factor and divide? No. I said if you need to find the scale factor, you do what? Everybody look, this is super important. To find the scale factor, you divide new over old. Now honestly guys, you can just use your alpha y equals button to simplify because we're going to leave them in fraction form. Okay? What has to go on top though? The new one. What has to go on bottom? The old. Remember how we have to figure out which shape is the new one and which one's the old one? So that's all you're going to do is take two numbers from them, put them in a fraction, and then there's your rule. Okay? All right, some things you need to know. And these are stuff I've already told you, but let's just go over it. If you're given the scale factor, you're always going to use it as a multiplier. If the scale factor is bigger than 1, it's going to make it an enlargement. It's going to make it bigger. If the scale factor is less than 1, it's going to make it smaller. It's going to make a reduction. Now, I'm going to give you all a second to answer these two questions on your own. This is part of your assignment today. I need to see if you understand it. Everybody look at your own paper. Read the first question. Guys, here's a clue. Change the number to a decimal. It will tell you if it's greater than 1 or smaller than 1. Go. I shouldn't hear you. I should see you reading. I'm going to call on the person I don't think is doing it. Okay, let's talk about it. If I take a shape and I dilate it by a fifth, would it make a shape bigger or smaller? Well, what is a fifth as a decimal? 0.2? 0.20? Is 0.2 bigger than 1 or smaller than 1? That's tiny, right? So is it going to be a reduction or an enlargement? Reduction. All right, do the next one on your own. Change that number to a decimal. Okay, what is 3/2 as a decimal? 1.5. Is that number greater than 1 or smaller than 1? So would it make a reduction or enlargement? All right, this is part of your assignment. Does everybody understand it? Okay, flip to the back. Now, you are going to be given pictures. This is most of your assignment, and I'm only going to do 2 examples with you, so pay attention. Does everybody see the 2 examples? Your job is to write a rule. Remember that your rule will be take X and Y and multiply them by something. Your job is to find the something, the number that goes there, the scale factor. Yes? How do you find the scale factor? New over old. Guys, this is super, super easy. Okay? The hardest part is figuring out which shape is new and which shape is old. You do not get to pick. Does everybody understand? If the shape has primes, everybody look. If it looks like this, these primes mean new. But what if it doesn't have primes? Then you have to read. Like, what if neither of them have primes? The question will tell you, so you have to read. So everybody look at example 3. It says, figure S was dilated to create figure T. What does that mean? If I created figure T, that means T is the new shape. So you go put a new on figure T. Does everybody understand? That means S is the... Now, you have 2 options. Pay attention. You can choose to count the side links of something, because you need 2 numbers. Does everybody agree? I need a number for the new shape. I need a number for the old shape. You can use side links, or you can use coordinates. and it will give you the same answer. I'm going to show you both ways. So the first way, I'm going to show you the side length of this one. See this side length right here? So I can go count 1, 2, 3, 4. Does everybody agree it's 4? So new was 4 over old. What is this right here? 2. And then I would just simplify it. So I go to my calculator. Y'all should know this, but let's just do it in the calculator. Go to alpha y equals 4 over 2 simplifies to 2. That means the scale factor is, so that's my answer, 2x, 2y. But pretend we didn't use the side length. You could also use a coordinate, okay? It just has to be in the same spot, okay? So everybody look at the new one. What is this coordinate right here? 0, 6, and this one is 0, 3. So just use 6 over 3. What does 6 over 3 simplify to? 2. Did I get the same answer either way? So you get to pick, and sometimes you don't get to pick. Like, look at the second problem. You can't count a side length of a circle. You have to use the coordinates, right? Some of them, the coordinates might not be good, but the side lengths are. So you have to use what they give you. Now, real quick, we have to write a rule. My rule says, take my x and my y, multiply the x by 2, multiply the y by 2. And that's my rule. Easy? Okay, you all try the next one on your own. Remember, new has to go on top. Figure out which one's new, which one's old. Find 2 numbers, 1 for each. Put the new one on top. Just normal. And we do want to leave these as fractions, unless they simplify to a whole number. Okay, which one was new? Because it created circle 1. Yes? All right, so this one's new. This one's old. Now, guys, if you switch them, your whole answer will be wrong, okay? You could not count side lengths, but did they give you a good coordinate here and here? So which number would go on top? 3 over. Now, put it in your calculator because it could simplify. 3 over 8, does it simplify? Leave it as a fraction in its simplest form. So 3/8 stays 3/8. And my rule says, take my x and my y and multiply by 3/8. And that's it. Questions? Okay, your assignment will be found in the Google Classroom. I will only check your paper one time. When you are finished, you are to get on IXL, Section R, and do something with dilations.